Welcome to Chem Time.
Hello viewers, welcome to the YouTube presentation. Today's presentation will be discussing about inverted YouTube manometer, and this presentation on inverted YouTube manometer will be useful to agricultural engineering students, civil engineering students and mechanical engineering students. Along with this presentation, we take up one gate problem and one need problem also. Coming to inverted YouTube manometer, this manometer is basically meant for measurement of small pressure differences, and the manometric fluid in this type of manometer is usually air. All of us know the density of air is relatively less, and the working principle of inverted YouTube manometer is same as that of YouTube manometer, except when the pressure is calculated at the reference point, it is the difference between the dynamic pressure and the static pressure. The inverted YouTube manometer is shown in the figure. The density of the liquid that is flowing in the pipeline is denoted as rho, and the manometric fluid is having a density of rho m, and the reference point is taken as x dash. The pressure at x is P1 minus rho g into h plus a, where P1 is the dynamic pressure and rho g h plus a is the static pressure. Pressure at x dash is equal to P2 minus rho g a plus rho m gh. Since both and x and the pressure at x is equal to the pressure at x dash, the equation simplifies to P1 minus P2 is equal to rho minus rho m into GH. Most of the cases, the manometric fluid is a rho much greater than rho m. So the equation simplifies to P1 minus P2 is equal to rho GH. Now, the gate problem that is given in 2017 is a manometer is used for measurement of pressure in a closed tank. The three fluids have specific weights gamma, 2 gamma and 0.5 gamma respectively, and they are denoted as F1, F2 and F3 in the figure. The schematic arrangement with manometric readings and other dimensions are shown in the figure. In order to ensure zero cage pressure in the tank at the mid height level, that is h by 2, the height of the tank is to be. It is given in 2007 GATE examination. The reference point is taken as x dash, and the pressure at x becomes equal to the pressure at x dash. Zero cage pressure can be converted into absolute pressure by adding atmospheric pressure to the gauge pressure. The atmospheric pressure is 101,325 newtons per meter square. The pressure at x is influenced by three. One is the dynamic pressure because of the gauge pressure, one because of the height due to the liquid 1, and the other due to the second liquid, that is 0.2 meters. So the pressure at x is equal to the gauge pressure, that is 101,325 plus h by 2 plus 0.6 into 0.5 gamma plus 0.2 gamma. Pressure at x dash is equal to, on the other side of the YouTube manometer, the manometer is open to atmosphere. So here also the pressure is atmospheric, that is 101,325 newtons per meter square plus 1.2 gamma. Equating these two, we get 101,325 newtons per meter square plus h by 2 plus 0.6 into 0.5 gamma plus 0.2 plus 2 gamma into 2 gamma rather is equal to 101,325 plus 1.2 gamma. And we can get rid of the gamma because it is common in all the equations, and 101,325 gets cancelled out. So this gives h is equal to 2 meters. Coming to the need problem, a vertical U-tube of uniform inner cross section contains mercury in both sides of its arms. A glycerin, whose density is 1.3 grams per cc, column of length 10 centimeters is introduced into one of its arms. Oil of density 0.8 grams per cc is poured into the other arm until the upper surface of the oil and glycerin are in the same horizontal level. Find the length of the oil coil. The density of mercury is given as 13.6 grams per cc. Since both sides are open to atmosphere, the difference is only because of the static pressure. That is, the pressure at x is equal to the pressure at x dash. The pressure at x is equal to rho gh, that is 10 centimeters into 9.8 meters per second square into 1.3 grams per cc, and this is the pressure at x. The pressure at x dash, there are two components. The h is covered by oil and 10 minus h is covered by mercury. So 10 minus h into 9.8 into 13.6, the static pressure due to 10 minus h, plus h into 9.8 into 0.8 grams per cc. When these two equations are combined or equated rather, the answer for h is equal to 9.6 centimeters. So the correct option is 4. Limitations of YouTube manometer are: speed of response is low. When we discuss the topic on process control, we'll be knowing more about the speed of response. The second limitation is the height of the YouTube puts a limitation on the pressure measurement. Higher the pressure, higher the height of YouTube, and henceforth may not be in a position to use YouTube manometer for pressure measurement. Surface tension can inflame the pressure, and the presence of dirt or other contaminants in the manometer fluid can affect the fluid density and the accuracy of the readings. In cases where the fluid in the manometer is viscous, it may not respond quickly to pressure changes, resulting in a lag in reading. With this, I conclude my presentation. Thank you.
Request you to like, share and subscribe my channel.